So now we're moving on to something a little different. Ronan, where do you stand on completing the square from school?
I don't remember. I remember doing
Yeah,
it though.
well, very few people know it, and that's kind of what this is all about. You know, the SAT is a content-based test, so by narrowing the range of concepts and getting really deep into those concepts, they're kind of challenging students across the world to, learn these things that a lot of them wouldn't have had a lot of reason to know otherwise. So completing the square is really big. It's definitely something you need to be good at in order to succeed on the SAT. So in this situation, as a nice example of it, a quadratic is in the format of ax squared plus bx plus c. So we're talking about b over 2 squared. So we're talking about that second number, which in this case is what number?
6x.
Yep, the 6 that's in front of the x, right? So in completing the square, you want to kind of get just the x's by themselves first. So I'm just going to add 2 to both sides first. And then for b over 2 and b over 2 squared. So b is 6 divided by 2, and you get 3, and square that, and you get 9. So b over 2 is going to be what it factors to when we're done with all this. And this is going to be what we add to both sides. So right now, we're just going to add 9 to both sides. And what you're doing when you do that is you're creating a perfect square. So I could ask a student here, what are 2 numbers that add to 6 and multiply to 9? And a lot of people know the answers to that question. But the beauty of this method is we already knew in pink here what it was going to factor to, which is the number 3. So x squared plus 6x plus 9 factors to x plus 3 squared, right? And now this gives you a situation where you could solve for x. So Patrick, walk us through solving for x here.
You can take the square root of both sides. Or you can take the square root of both sides.
Yep, that's my preferred method. So now you always need a plus and minus. So plus and minus root 11 equals x plus 3, then what?
Then you can subtract 3 over.
Negative 3 plus or minus root 11. So on a lot of questions we'll have nicer numbers than these. But negative 3 plus or minus root 11 is just fine. So it takes a little memorization, right? You've got to spend a little time saying to yourself, b over 2 squared, and knowing that b over 2 is what it factors to, b over 2 squared is what you add to both sides. And this gives you another method because even though it's a little weird at first, unquestionably, it's less writing than you would have to do with the quadratic formula, right? So Ronan, would it seem like it would be easy to learn how to do this or hard?
I'd have to go over it a couple more times, but it's definitely quicker than the other way.
Cool. So let's try one more. I'm just going to go ahead and put the rules on the screen if my computer allows me to. Alrighty. So do you remember what we did first on that last one, Ronan?
Yeah, you found b over 2, the second number.
And a tiny little step before that, just to kind of clear out this guy. This guy is kind of a nuisance in the completing the square thing. And I am forgetting one even more fundamental thing, which is that all of these are divisible by 5. So in our last lesson, we emphasized that we really want to get rid of
Greatest common factor.
Any GCFs, as I said, without explaining that it was the greatest common factor, right? Okay, so then that other step, we want to get the C out of there. Okay, and what do we do next, Ronan?
Now you're taking your 14, negative 14.
Mm-hmm.
And you're going to that other one.
Divided by 2, right? What do you got?
By 2. Then you're adding something.
Yep, so you divide it by 2, and then b over 2 squared is the idea that you square that. So we've got negative 7 is what it's going to factor to in the end. And 49 is, like you just said, the thing you add to both sides. So we add that to both sides. And what does all this factor to? So we got 48 on this side. And what about that thing I circled there?
what does it factor to? Oh, like square root.
Mm-hmm. So feel free to jump in, Patrick.
So it'll be the perfect square. So here, what it factors to is the second. So you see we have the b over 2, the b over 2 squared. So the second number that we found, -7.
So x minus 7 squared.
squared.
So like if we said in factoring, which is what you guys were doing in your last lesson together, what two numbers add to -14 and multiply to 49, then the answer would be -7 and -7. So it would have factored like this, right? But then this is just a more sort of fancy way to show that, just x minus 7 squared. And then what do we do to actually solve for x now, guys?
Square root both sides.
Square root of both sides. So we've got root 48 plus or minus root 48, because whenever you take a square root, you need a plus and minus, is x minus 7. And what's our last step to find x?
Add 7.
Add 7. So x is 7 plus or minus root 48. Okay, so just a quick recap. When we first started this, we were talking about regular BC factoring, two numbers that add to this and multiply to that. Then we started talking about the quadratic formula as another option if factoring doesn't work, and the discriminant is part of the quadratic formula. It tells you how many solutions. Now we completed the square, so we're kind of going item by item through all the things you need to know about quadratics, and they come up super frequently on the SAT. Anything to add, Patrick, before we go to the next one?
No, I think that's good. Just looking for the timing there, but I guess we can keep on going. Depends how long we want to go for today.
Yeah. So maybe just under 6 more minutes, right?
It's good with me, if it's all right with Ronan.
All right. So we've got this situation. So another thing to know is if you have a 2-term quadratic, you want to use GCF, which is what again, guys?
Greatest common factor.
Greatest common factor. Exciting stuff. So what's the GCF for these two terms?
5.
5. And how many x's?
What do you mean how many x's?
Well, this one has 2 x's, right? Because it's x squared, and this one has 1x.
1x.
Yeah, so 5x we can take out of both of these. And when you do that, what remains when you factor out 5x?
3x plus 7.
3x plus 7. So in other words, 15x squared divided by 5x is 3x, and 35x divided by 5x is 7.
Oh, okay.
So now, well, okay, let's just say we are factoring sort of the BC factoring. I'm just putting a random example up on the screen. So x squared plus 7x plus 10. And like I said, we start these by usually setting one side equal to 0 because we're looking for x-intercepts. And then it factors. Two numbers that add to 7 and multiply to 10 is x plus 2 and x plus 5, right? Now, this is something that we do so often in math and don't even think about it. It's called the zero product rule. It says that we have two things. These two things that I'm going to highlight in blue here, they're multiplied together and the answer is 0. So mathematically, it's only possible if one of them is 0. So the zero product rule says one of these things must be 0. Let's set them both equal to 0. And that's the way we get from having our factors to having our actual answers or roots or x-intercepts or whatever you want to call them. So the reason we're bringing this up here is that even though we got there by a different method, we've got our two things right here. And they're both multiplied together and they both give you 0. So what should we be doing next then?
The same thing, the zero product rule for each.
So just set each one equal to 0. And we get 0 here. And here we have 3x is minus 7. We take away 7 from both sides and divide by 3. So for this problem here, we end up with x is 0 or x is -7 over 3. Okay, so Ronan, your turn. What can we do first here? We have a 2-term quadratic.
Okay. You're gonna want to find the GCF. So
Say is what?
do 8x.
Okay, and that leaves you with?
-2.
Well, okay, so we have 2 and x, right? Because 2x times 8x would be 16x squared, right?
Yeah.
And what about for that next one?
6.
6. Okay. Now, the funny thing is here that these are tough numbers. These are both divisible by 16, right? Are they?
32, yeah, 48.
No, 48 actually. Okay, no, I'm like, yeah, 48 is divisible by 16. It's 16 times 3. So we could have taken out a 16, but that's totally fine because this will work no matter what. So assuming we had the GCF already, then what do you do next?
I don't even remember. I can't scroll up.
A lot of info at once, right? Which is the moral of the story for the SAT. It is a lot of info, and we don't want students leaving it till the last minute. This stuff can only be learned if you're doing it very little by little, memorizing a couple of these every day, because it's not aptitude like the old SAT. It's not like an IQ test, it's content. And when we know that content, we do well. Okay, so what's the zero product rule here then?
You're going to split both terms.
At both sides, right? Equal to 0.
Yep, 8x equals 0, and 2x minus 6 equals 0. So divide by 8, add 6, and we get our answers of 0 and 3. Now, if we had taken out 16x, so you get 16x, and that leaves you with x minus 3, just a little on the fast side. 16x equals 0, x minus 3 equals 0. And the idea is that you get the same two answers. So, okay, so we've gotten this up to when you have a 2-term quadratic like we have here, we use GCF factoring. Anything to add before we wrap up, guys?
I was just going to say, as you mentioned, there's a lot of little rules and you need to study a lot. So if you're prepping, if not, make sure you tune in each day so that you can get a little more and more info and improve each day, as we're doing with Ronan today.
Yep, that's it. Spread the word at your school, right? Because there's so many people in need of help on the SAT. Maybe some of them can't afford tutoring, and there's this amazing free resource. And so we just want to get the word out there. So, hey, Ronan, thanks so much for joining us. We really appreciate it.
Yep, thanks for having me.
And you can stop by whenever you want. Free SAT help from 2 guys who've been drinking a little too much coffee today. All right, guys. So have a good one, okay?
Yep. Talk to you later.
All right. Take care.